Hi, today I would like to show you how you can model 3D shells in SCIA Engineer. The question was coming from a customer. He asked me to create a tunnel tube, but not in a straight line, but in a curve. Therefore you need these general shells in SCIA Engineer. My name is Ivan Beleš and I am support engineer for SCIA Engineer and IDEA Statica. And now we are in SCIA Engineer. This is a completely empty project with no settings. I go to these settings, so the settings of the object snapping. So this is the standard which we will have here. So how can we generate it? So go to the structure. There is one command for this, and this is this shell command. What does it do? You can create a 3D shell from 4 logical lines. So for example, line number 1, line number 2, 3 and 4. So 1, 2, 3 and 4. You know what happened? The line number 1 and 3 will be interpolated. So we get from an arc, we get a straight line. And the 2 and 4 are lines, so they'll remain as lines. Another possibility is, for example, you have an arc and a second arc. And let's say, so these 2 arcs. What will happen? We have 1, 2, 3 and 4. This is an arc. This is an arc, and it remains an arc. So it will not go like this, because then we would have from arc we would get a line, and then from line again an arc. So this is another type of modeling. If you model it with 4 arcs, then we get this type of structure. If you want to have this, then you can create this from 2 parts or 4 parts. Let's say 2 parts. So this is the first one, second, third and fourth. So, and from this arc, this is something like this, only in opposite way. And on this way, you can create almost everything in SCIA Engineer. I use only this option. I use the translation and rotation shells only during training, but usually I do it only with lines. You can reduce it to 3 lines. This is also working. So there are some special cases where you can use it. So first what we will do is this tunnel section with an arc, with a curve top view. So for this I will generate some lines, and in the German video I have created more layers, so I will not play with the layers. We should do it quicker. The German video was over 40 minutes. So this is a line. I use the circle, start with 0, enter, and go to 2, 4, 6, 10, 20, let's say 20 meters. Okay. Escape, or you can do escape on some mouse key. So the next line, again a circle from here. I use the shift button from here, 3 meters, and again the next one from here. Oh, and with enter you can repeat your last command. Again a circle from here. With shift I use this. So I push the shift button, go with the mouse to this point, but I don't push some button on the mouse. I release the shift button on the keyboard, go to the right, and 3 meters. Okay. So we have some lines in the top view. Let's look on it from here, and then I will create some horizontal lines from the center to here, okay, and activate some line division, 16 points, okay, this is okay, and create some point from here to here, and from here, escape, and from here to here. Okay, escape, escape, escape until it's finished. So, and what we will do now is the first line, second here, third and fourth. This will be our tunnel section. To create this vertical line, you can draw it if you want. For example, go from here 3 meters to the top, but you don't need it. So we can work also with this tracking guides. So I start this shell, change it to concrete. In the German video I have created also the steel structures from concrete, but it doesn't matter. Okay, the first one, or all circular arcs. So I go to circular arc from this point over this point here. So, and now I need this one, so I go again with arc over this point, but I don't have this vertical line, so I push the shift button, go to this point, vertical 3 meter, and here. So, and again, so after you finish your arc or some spline or polygon line, it jumps back to straight line, to straight line. So, and again, arc from here to here, and again, arc from here, to here. Okay, it was not correct. Doesn't matter. We have a point and we can move it. So, and the structure is done. So it's very quick, and I think also very easy. So basics. This is what the customer asked. So another basic functionality. I go with the shell from, let's say, from top view. I start with an arc. I start each time if I have an arc or spline or something else, I start with this line and then I continue with the straight line. So start with the most complicated thing you have there. So from here, this is an arc, but I go with the straight line. 3 meters, 3 meter. Arc is finished. Then I am back in straight line, 6 meter, back 6 meter. And you can push escape button, then it's finished. So this is my structure, and then you can simply select it and move over 3 meter to the top, and you have your structure defined. So it's very easy. The next one, okay, let's say this is too short. It's minus, let's say minus 3 meter. 3. Okay, better. It's longer. We will create also an intersection with some vertical tube. The next one, which is often asked on the hotline, is a conversion from a rectangular silo, for example, to a circular output from the silo, or on opposite way from circular silo to rectangular output. I don't know what is better. So for this, I will create some lines. So again, top view, start here. Let's say we start from here, go 1.5 meter. Okay, I don't need all these points, I need the midpoint, okay? And then I go from here, shift, hover this point, go to the bottom 0.75, to the top 1.5, okay. Escape, escape, escape until they are selected. Now I can copy them from here over 3 meter, and this can be extended. Extend by defined length. The length is 0.75. So this and this. Okay, Now we will create a rectangular here and circular on the bottom. To make it really easy, I start with here and select this point, select this point, this one. Then it will be not necessary to generate these points later. Okay, and now what I like to do is to have here vertical lines, here a circle, and here one polyline. This is one polyline. Let's say this is 1, 2, 3, and 4. And from 3, slowly we will get an polyline from arc to that polyline, and vertical we will have straight lines. So how to do it? It's also very easy. Shell, change it to steel. In the German video I have created it also from concrete, let's say 10 millimeters. Okay, so what should I start with the arc from here to this point. It doesn't matter if you go with the circle or counterclockwise, clockwise or counterclockwise, it doesn't matter. So after I'm finished with the circle, it jumps back to the straight line, so I can simply draw it, and then I use this polyline, line strip, this is a polyline, over these points, escape, and I can finish with a straight line or simply push escape, then it's done. Okay, usually there are graphic settings, and okay, this is the default. Okay, let's say this is the default, and we can mirror this structure. There is a function for mirroring here, or better here, then you will know where is it. Mirror over these 2 points. I will not remove the old part. So, and you see this is not very nice. This has nothing to do with the settings of the finite element size of the shells. This is only a graphical representation, and this graphical representation can be changed here on geometry settings. You have here this shell precision of surface, let's say, change it to 5. So this is still 15. I click on watch this point. Okay, and you see it's better. You can use also this one, but I have seen this at not so big influence. It's a little bit better, but not so much. But you can test what is better for you. But this is the setting for the shell precision only. This is not for the generation of the finite element mesh. This is simply only for the geometrical representation. Okay, that was very easy. We are still at the geometry. Look at the intersections. I can draw some vertical tube here. This is the easiest way. I don't want to make it too complicated. We can use the function wall. It's also a very great way how to generate shells. I go again back to the concrete. Let's say 200 millimeter is the thickness. Okay, the height is okay. I use circle and put it somewhere. So it should be okay. Okay, so back about the rotation. Maybe you don't know it. For example, I have this picture and I want to rotate it. And if you know rotate, you see it goes out of your picture. Why? Because the rotation center is the center of the structure. So, but if you select something, then the center of the rotation is the center of this something which you selected. So if I select this, then I rotate over this of the center of the structure. So you can select also one point if you want, for example this one, and then you rotate over this point. So this one point stays in the middle or will not move on your screen. So now we need to calculate this intersection line. There are more ways. You can run the calculation, but we don't have supports and loads, and so this is not a good idea. During the calculation, the intersection lines will be generated automatically, but I will see it now before of the calculation. Then you can go to modify and start connect members and nodes. If you have selected nothing, then it runs over the full structure and connects everything. If you select these two parts, then it's run over these two parts. So I will save it. And there is also one function is here, intersection, and then you select your parts. Oh, this one. Select other members, this one, and escape. Then it's done only for these 2 or 3 parts what you select. So there are 3 ways how to generate it. Now we have this intersection line, and we can say which part, because this intersection line divides my 3D shell to 2 parts usually, and I can say which will remain in the structure, which should be removed. Removed means it's not really removed, it's only invisible, because if you change something, it has to be regenerated again and again. So, but you can delete it also. Cut out. Let's go, so escape. I look on with transparency view, back to cutout, select this and this part, escape, and now I see the lines. So from this horizontal structure, I will remain the inner part, and from the vertical tube, the bottom part. So, and now it's done. Transparency is out, off, and you see the structure. So it's quite easy. And if you change the structure, this will change again. You can, I have some papers. So, back to the shells. You can make visible the numbers of the lines. Right mouse button, view settings for all entities, and then there are labels, and there are labels of slabs, name, and there are edges. Apply, and then we see all these numbers of the edges. And go back, right mouse button, view settings, labels, and we can put them off. Then you see these gray lines. These are these cutouts. They can be also made visible or not visible. This is in structure and cutouts. You can deactivate the contour, or you can deactivate completely the cutouts. They are still there, but they are not visible. I don't know why, but it's possible. Okay. And if you want to have really clean pictures, for example, this shaded model, and you want, or transparent model, and you don't want to see these nodes and everything, then you can go back to view settings, structure, and structural nodes. And then you have, you can also deactivate these intersection lines. Then you get some clean structure for your output, for example. So go back. I will need the nodes. Okay, this is the numbers. Okay, mesh. We can generate the mesh. The mesh size can be defined in mesh settings, but I can simply generate it. It's not so nice, but it's okay. So I don't see the mesh. So you can go over right mouse button, view settings, and then you look on the settings and then the mesh, and then you can apply, and then you see the mesh. So there is a quicker way. So I will remove it. There is this view. I don't know how is it in English. View. Let's say view parameters, regenerate view. View nodes. Okay, this is right mouse button, view settings. It must be view. This view settings. And you can move this button to here, somewhere. And then you can click on it, and then you get some tree, and then you can go to structure, for example, and activate or deactivate mesh. So in view settings, you can get some quick access to the most important view settings. Okay, then go to the structure. Control E is to activate only selected members. Look at the coordinate systems of the finite elements. So I will deactivate the lines. I don't like them at the moment. I go to modeling drawing, deactivate the lines, and I will activate the local axis structure mesh, local axis of mesh elements, apply or OK. So first you see some of them goes out of the structure, some of them goes in. X is horizontal. This is standard for 3D shells. X is standard horizontal, but I want to have X vertical and I want to have Z going into my structure. This is very good for nonlinear structures, nonlinear calculations, because if you have, for example, a slab, then slab, the Z is going to the top and the surface support is on the bottom. If you have a linear calculation, then it's like rubber, it's going in both directions. But if you have nonlinear calculation, it pushes and it creates resistance. If it goes in the positive Z direction, then it's decoupled, then it's free. It has no resistance, the support. So it's better to go with the Z into the structure, and on the opposite Z, on the minus Z side, there is the support, if you need some support. So first I select this part and I simply, so if you don't see all properties, then click on this button, swap orientation and refresh the mesh, regenerate the mesh, and then I see everything, all Z axis goes into the structure. That's okay, but some of the X is going to the top and some of them goes to the bottom. So, and I don't want to have it. The possibility how to change it is here in local coordinate system type. There are some things that are used for 2D, for example, this perpendicular to vector, and this is for plates. If you want to rotate the coordinate system, congruent with the line is also okay. Smallest angle, you have to try which one is better for you, and you can also work with a vector to defined point. This is, for example, very good for circular plates. Then you can generate the tangential and radial reinforcement. So try to go with congruent with line, and then you select the point from this one to from this and these points to this one. Let's try it. I didn't done it in the German video. Generate mesh. Okay. Control E. And what we see is it goes nicely with an angle. This is a very good way if you want to have it going to the center of your structure. But if you want to have it really vertical, then Control Q, then we see everything. Select this, Control E, and let's say select only this one, or leave both them. So I select this one, go to the smallest angle, and select this point and this point. Let's look on the result. Generate mesh, and you see some of them goes vertical and some of them are inclined. So this is no, Control E, they go vertical. They are each time vertical, and the another ones are with an inclination. So you can play with it and check the result if it is what you want. So some of them are vertical, some of them are, oh, they are not vertical. I have to check it again a little bit. So this is the possibility how to change the coordinate system, get your direction which you want. I have to create an extra video for this coordination system. Okay, this was it. Okay, supports. They are very simple supports. For example, mostly these line supports onto the edge are used. They can be generated in global and local coordinate system, but local coordinate system not on arcs or splines. So therefore I use global coordinate system with an hinge that we have supported everything. So I select all these lines to get the supports, and here on the top, for example. And you see this is going in the vertical direction, and I cannot change it to local coordinate system. Small trick, if you want to have local coordinate system, you can create a 1D member. I would use some cross section, so let's check what is it. What is this? This is a concrete 20 centimeters. So I would use some concrete section, but not 20, let's say 100 to 100 millimeters. It's not necessary. Okay, okay. And then I want to draw it over this line. Sometimes it's not so easy if you have some spline which was imported from a CAD software and so. Then you can use this select line and select your line. That's all. Then you have the copy of your line also with your beam. So I can now delete this support on the 2D edge, and I can add a support on 1D member, and this can be generated also in local coordinate system. I say it's hinged, and X is free. This is also free, and also only Z and only this point. So if I select it, then I see it's each time perpendicular. So this was about supports, small trick. Then we had these intersections. It's also explained. Support loads. Very often with these 3D shells you will use free loads, and there is one small point, so I will explain it very shortly. This is not special. I have a special video about these free loads, but let's say I want to load only this part, which has height of 1 meter, and I want to load it perpendicularly to this shell. So what can we do? First, I have to move my coordinate system to some point. Move to this point. And now I want to move it 1 meter in negative Z direction. So again, move 0, 0, minus, minus 1. Okay. Look from, let's select only this one, Control E from the top view. And now I want to generate the load. So I go to load cases, create a new load case. So, and I will use from loads this free surface load. We will change all these settings later. Now I need only the geometry. And what I need is line and line, the arc and line and arc. I am in the vertical position 1 meter below of the top. So now I can simply click on the points, first point, second point. I use the arc from here to here, and then again straight line. And you see I'm not on the bottom because here is my coordinate system, and everything will be drawn on the 0 level of the coordinate system. So I can close it with this point and go here. So it's very nice. So we have support, we have loads. I can run the calculation. It's very rough mesh. It's half meter, but it's okay. Aha, it's not correct. So it's gray, that something is weird. So I have to select it again. So, and there is defined, its validity is Z is equal 0. So this is used for plates. But we want to load from 0 to 1 meter in the top. So I change it from 0 to 1 or 1.5, doesn't matter. It's uniform load minus 3 kilonewton per square meter, and it's in local coordinate system of member. That means in each finite element coordinate system. Okay, now run the calculation again. We can also generate the loads, but I need the result. So, and then you see the generated load. Disadvantage is that you cannot edit this generated load. Therefore, you need sometime the original, sometime the generated load. Right mouse button, view settings for all entities, go to the loads and masses, and then you see the generated or original or both of them. Apply, and then you see this one which can be edited, and this one which is generated. Looks nice. In the old environment, there were this 2D data viewer which could show us the generated surface load in colors of finite elements. If you want to have it, then you can go to the results. Here are also surface loads. You can select the load case. Say if you want to see it in local coordinate system of the element, this is then constant load. You see only one value. I will change the colors to smooth. Okay, refresh. So this is one constant color. But if we go to the global, then we have here vertical. Okay, this will be something about 3, but now here it goes in this direction, so that means the vertical part is a little bit smaller. So here we have 2.28, and here we have a little bit inclination 2.99, not directly 3. So this is the generated load. So you can see it on more ways. So next point, loads, check the loads. We are in the finish. Results. Okay, this is okay what I see. Let's go out from these results. I want to see bending moment. So you see this is X is horizontal, Y is vertical, so My I want to see. So I go to the internal forces from the second load case, My, and then I see the results. But sometimes you really need some line with the results. Not everybody likes these nice colored pictures. You can use sections, and this is a good way to explain sections. Section is a line which is moved through the structure. It cuts the structure, and everywhere it generates cuts. You can display the internal forces. You can make an integration of these internal forces. There are more possibilities, but we do it very, very simple. I will activate now these line divisions. Go back from these results, and I need the section. It's here because I moved it here, so you can use it section on 2D, and then you can move it here, but usually it's not there. So I will select it from here. This will be changed later, and I draw a line from here to here. So it's on the Z0 because I selected these nodes. So and now I can display the same results like before, like these results, but on the section. So I can change it to sections, deactivate the standard results, and this is My. And we can say we want to see for each mesh node the results without units. But I don't like this vertical representation. I want to have it orthogonal, so you can change it into the, you can change it here, but I think it's better to change it directly here, and you can say upright to element, so it's orthogonally to element, and this is what we need from the results. If you want, you can combine all these 3D results evaluations with clipping box around selected entity. This is my only my section, and I can select it. I can rotate it a little bit, so better, make it higher and wider, so I see one section of my tunnel tube. So, and then you get your results. Okay, deactivate it. We are in the finish. Control Q to see everything. So that's all. I hope it will help you. Thank you very much. Maybe you will see some next video. Bye.